Problem A4. Note that 49 is equal to 4 times 9 plus 4 plus 9. How many two-digit numbers are equal to the product of their digits plus the sum of their digits? Now, to do this problem, we need two skills. We need from computational thinking, pattern recognition, and also we need to have this essential skill when you solve these problems. This is a bit of a trick you can use when you do problems that involve checking, like this one. We have to check if this condition is true. Now, this method is called, well, literally called, being dumb. Yes, and you are going to be dumb when you do this question, but then you're going to become smart. So let's just start with this problem, and you'll see why these two skills come in use. So first, being dumb, we just test out all the possibilities. There are 90 two-digit numbers. We're going to be very dumb and just try everything. So we have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's start with that first. Okay, 10. 1 times 0 plus 1 plus 0. That gets us 1. So clearly not. So we can rule out that. Next, 11. 1 times 1 plus 1 plus 1. That is 3. So still clearly not. Then you have 1 times 2 plus 1 plus 2. Now that's starting to get interesting. 5. Then you get 1 times 3 plus 1 plus 3. And now you get 7. It's very interesting. Let me just rewrite the results. Then 14, 1 times 4 plus 1 plus 4. At this point, you could just guess. 9. And so on. It's going to be 11, 13, 15, 17, 19, and boom, it matches. So we just find 19. And now what we just did with the 1, 3, 5, 7, 9, we found a pattern and we became smarter. So we didn't have to test all of the other ones. So now we know that 19 is a match. We're going to write it aside here, 19. Now let's do 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. Let's do all of these. Okay. 2 times 0 plus 2 plus 0. That's 2. Now I'm just going to erase this for a bit of space. 2 times 1 plus 2 plus 1. It's a bit interesting, don't you think? Then you have 2 times 2 plus 2 plus 2, which is 8. 2 times 3 plus 2 plus 3. And at this point, we would have found a pattern. They increased by 3. Now, just now, it increased by 2. Right? There's 2, 2, 2. And now increased by 3. So the increase between the numbers is increasing at every different 10. So we can find from here, this is increasing by 3. Just now, 10s were increasing by 2. So it increases by the 10, which I'm going to call n, plus 1. And that is important because of the 2 here, we have 2 plus 1 is 3. So it increases by 3 every time. It also starts at its 10. So the first one of 10 is 1, then 2, then 3, then 4. Now, if you apply the rule, and we find that when you multiply by 9, it is the only time it actually turns out to... So this becomes that, which becomes 10n plus 9. And then that's good. Because why? It's the actual only one that satisfies it. 10n plus 9 satisfies it. So the 10 becomes this 19. That's the only one that works. If you do something else, it's going to go in this array. It's not going to have this 10n, which is the important bit. If you did 8, which I'm going to do here, Then you get 9 and plus 9. Sorry, plus 8. And you can't do anything particular with that because it's going to go into other tens. So therefore, we have just found a big pattern. It's going to be 19, 29, 39, 49, all the way down to 99. And how many is that? 9. That's our answer.